Hello everyone, I am today's lecture teacher, Loi Chao. Today we continue to study the second task of Project 6, Awareness of the Cockpit Environmental Control System in the Aircraft Construction course, the Air Cycle Refrigeration System. The air cycle refrigeration system is the core part of the environmental control of the aircraft cockpit and is widely used in modern jet aircraft. Next, we will learn more about this system. This mission mainly includes two parts. One is overview of the air cycle refrigeration system, and the other is detailed explanation of refrigeration components. We will gradually carry out learning in this order and deeply understand the composition, principles, and functions of each component of the air cycle refrigeration system. First, let's go to Part 1, Overview of Air Cycle Refrigeration Systems. This part will introduce the development history, composition, and basic working principles of the system and help us establish an overall understanding of the system. Development of air cycle refrigeration systems. Currently, the most widely used types of air cycle refrigeration systems on most jets, the system has gradually developed from the initial turbine ventilation system to a two-wheel booster system and a four-wheel booster system. With the development of aircraft multi-electric technology, the system is also constantly evolving. Some aircraft use electrically driven compressors as air supply sources, replacing traditional engine bleed air. At the same time, electric fans are used to replace the original pneumatic fans, which further improves the efficiency and reliability of the system. The composition and principle of the air cycle refrigeration system are as follows. First, look at the composition. It mainly includes a compressed air source and refrigeration components, among which the refrigeration components are a heat exchanger and an air cycle machine, also known as a turbine cooler. Let's look at the principle again. The high temperature and high pressure air drawn from the special cockpit supercharger or directly from the engine compressor will first pass through the heat exchanger and transmit the compressed heat to the cooling medium, usually the outside environment air. Then flow into the turbine for expansion, drive the turbine to rotate, drive the coaxial compressor and fan, convert the terminal energy into mechanical work, greatly reduce the temperature and pressure of the air at the turbine outlet, and obtain cold air that meets the requirements. Finally, the cold air and hot air are mixed in a certain proportion and then lead to the cockpit, providing a comfortable environment for the cockpit and pressurizing. In order to achieve better cooling effects, ram air or fans can be used to increase the speed of cooling air flowing through the heat exchanger. This is the principle of the air circulation intelligence system. The composition of the refrigeration assembly, which is the core of the air cycle refrigeration system, includes one component valve, also known as a flow control valve. It is the switch of the entire component. 2. Heat exchangers. There are usually two units, a primary heat exchanger and a primary secondary heat exchanger. 3. Air cycle machine, ACM, also known as a turbine cooler, is a core component of the entire system. 4. Temperature control valve, also called bypass valve, air mixing valve, etc. The main function is to adjust the outlet temperature of the component. 5. Water removal device, used to remove condensate water in the air. According to the installation location, there are two types of high-pressure water removal devices and low-pressure water removal devices. 6. Ram air system includes ram air duct, ram air inlet, and outlet doors. In addition to the above-mentioned components, a variety of sensors are installed in the refrigeration assembly to feel the temperature in the assembly and ensure effective control and monitoring of the assembly. Downstream of the refrigeration assembly, a component one-way valve is installed to prevent air reflux into the assembly. Each component is controlled by a corresponding component controller to ensure its stable operation. After understanding the overview of the air cycle refrigeration system and the overall composition of the refrigeration components, let's move on to the second part, the detailed explanation of the refrigeration components. This part will introduce the structure and functions of each key component in the refrigeration assembly one by one to help us deeply understand the working mechanism of the system. Flow control valve. The flow control valve of the air conditioning system is also called a component valve. Its main function is to control the airflow supply to the air conditioning assembly, and it can also be used to isolate the air conditioning refrigeration assembly from the air source system. In general, when the flow control valve is open, the flow rate of air supply to the refrigeration assembly is controlled to a constant value under certain conditions. For example, for a certain type of aircraft, when the APU supplies air to the refrigeration component or only one set of components works, it is set to high flow by default, low flow mode, during takeoff and landing. In other cases, it is normal flow. Air cycle machine, also known as ACM. At present, the air circulation refrigeration systems used in civil aviation aircraft include turbine ventilation, two-wheel booster, three-wheel booster, and four-wheel booster. The type of turbine cooler. First, the turbine ventilation air circulation machine is introduced. The turbine ventilation air circulation machine is composed of coaxially installed turbines and fans. Its operating process is that the high-pressure hot air is cooled by the heat exchanger and then enters the turbine section, expands and cools in the turbine, and then enters the mixing assembly. The turbine drives its coaxial fan, which is connected in series with the heat exchanger in the ram air duct, to improve cooling efficiency by accelerating the flow of cooling air. So the aircraft still has a certain cooling capacity when it stops on the ground. However, since the load of fan work is much lower when the aircraft is flying at high altitude and high speed than when it is flying on the ground, and at low speed, the number of turbine rotations increases and it is easy to overrun, which affects the cooling effect and reduces the life of the turbine. Therefore, the aircraft equipped with this system must limit the flight altitude. Let's learn about the two-wheel pressurized air cycle machine, which consists of a turbine and a compressor. Its working principle is that the high temperature and high pressure air flows into the compressor after being cooled by the heat exchanger, and the pressure increases, and the temperature increases when it flows out. The heat exchanger receives hot air from the compressor and exchanges heat with the ambient air to reduce its temperature. The air then flows into the turbine, is expanded and cooled, and is fed to the mixing assembly. The turbine and compressor are installed on the same shaft, and the air circulation machine is driven by the turbine. The second-wheel pressurized air circulation machine has a large cooling capacity under high-speed flight conditions. But when the aircraft stops on the ground or takes off and rolls, due to the lack of ram air in the heat exchanger, the cooling capacity will be greatly reduced, and a special ventilation fan needs to be used to solve it. Compared with the turbine ventilation type, the two-wheel boost refrigeration system is a refrigeration system that enhances the refrigeration effect by increasing the inlet pressure of the turbine. Under the same refrigeration capacity, the required air supply pressure or bleed air volume is small, and the engine consumes less fuel, and the economy is good, and the turbine operates smoothly and has a long life. Let's learn about the three-wheel boost air cycle machine. The three-wheel pressurized air circulation components include the turbine, compressor, and fan, and the turbine drives the coaxial compressor and fan to work at the same time. It overcomes the shortcomings of turbine ventilation, and two-wheel booster retains its respective advantages, and is currently used in civil aviation aircraft. The four-wheel booster air circulation machine installed on some aircraft is composed of a two-stage turbine, a compressor, and a fan. Its refrigeration principle is basically the same as that of the three-wheel booster, which further optimizes the refrigeration effect and system stability, ram air system, and heat exchanger. The main function of the ram air system is to provide cooling air for the heat exchanger in the refrigeration assembly. Its composition generally includes the ram air intake valve and its actuator, ram air duct and exhaust pipe, etc. The ram air is introduced through the pipe, and the inlet and outlet are equipped with doors that can adjust the opening. The opening will affect the cooling effect of the heat exchanger, and the cooling effect is the best when the door is fully opened. When the aircraft is stationary on the ground or flying at low speed, the ram effect is weak. At this time, the fan or independent fan of the air circulation machine in the component can increase the flow of cooling air and ensure the cooling efficiency of the heat exchanger. Heat exchangers have cooling air inlets and outlets, and ram air is used as cooling air. The corresponding inlets and outlets are called ram air inlets and outlets, respectively. The two-stage heat exchangers installed in the ram air pipe are air-air heat exchangers. The cold path is ram air and the hot path is high temperature and high pressure air. Its structure is generally plate fin type, which can efficiently realize heat exchange. Dewatering system. In the air circulation refrigeration system, if the air temperature drops below the dew point, there will be moisture condensation, which needs to be separated by a water removal device to obtain dry and cold air. According to the different dehumidification positions, it is divided into low-pressure water removal and high-pressure water removal systems. Let's first look at the low-pressure water removal system. The principle of low-pressure water removal is downstream of the cooling turbine. After the high-pressure air is expanded by the turbine, the pressure and temperature drop, part of the water vapor condenses, and the wet and cold air is under normal pressure. At this time, a low-pressure water separator is set up to separate and collect condensed water, which is called low-pressure water removal. That is low-pressure water separation and dehumidification technology. To avoid icing and blockage in the low-pressure water separator system, it is necessary to set up an anti-icing or de-icing device. Generally, the control valve is used to introduce the hot air in front of the turbine for anti-icing or de-icing to ensure that the temperature is higher than 0 degrees Celsius. Let's look at the structure of the low-pressure water separator. The low-pressure water separator is limited by the structure, which has a great impact on the cooling capacity of the system and a large maintenance workload. Its main function is to separate and collect condensate. Let's look at the high-pressure water removal system again. The principle of high-pressure water removal is that upstream of the cooling turbine, the air is cooled in the condenser and part of the water vapor is condensed. At this time, the wet-cold air is in a high-pressure state, and the high-pressure water separator is used to separate and collect condensate water. The high-pressure water separator is the core component of the system and is usually installed on the inlet pipe of the turbine. Its main function is to remove moisture from the air and prevent the turbine from freezing. Recuperator and condenser. The high-pressure hot air supplied into the system passes through the first-stage heat exchanger, the compressor part of the air circulation machine, and the main heat exchanger, and then enters the regenerator and part of the moisture condenses. After that, it enters the condenser. A large amount of moisture is condensed and then exits the system through the high-pressure water separator. The above is the whole content of this air circulation refrigeration system. Through learning, we learned about the development, composition, working principle of the air cycle refrigeration system and the functions of the key components of the refrigeration components, which laid an important foundation for us to deeply grasp the environmental control system of the aircraft cockpit. Thank you all for watching. Now comes the exercise session. Students can press the pause button to think and answer. Let's start now. Have all the students answered correctly?